Dear students, in this video, we will discuss a rearrangement reaction of alcohols called Pinacolone rearrangement. This is a very important rearrangement reaction. We will also be discussing the mechanism of this rearrangement. So first let's see what are pinacols and pinacolone. Pinacols are completely substituted 1,2-diols. That is, the hydroxyl groups, OH groups, are attached to the adjacent carbon atoms. So this is the example of a pinacol. OH groups are attached to the adjacent carbon atoms. So such completely substituted diols, 1,2-diols, are called pinacols. Pinacolone is a compound containing a ketone functional group. As the name implies, pinacolone. This is an example for a pinacolone, which is a ketone. Now let's see what is meant by Pinacol-Pinacolone rearrangement. Pinacols, when treated with mineral acids, undergo dehydration and a rearrangement to form ketones called pinacolones. And this reaction is called Pinacol-Pinacolone rearrangement. This is an example. 2,3-dimethyl butane 2,3-diol, which is generally called pinacol, when treated with mineral acids, undergo dehydration, that is loss of a water molecule, and a rearrangement to form a ketone 3,3-dimethyl butanone, which is generally known as pinacolone. And this rearrangement reaction, that is from 1,2-diol to a ketone. So this rearrangement reaction is called Pinacol-Pinacolone rearrangement. Now let's understand the mechanism of Pinacol-Pinacolone rearrangement with the help of an animation. This is a 3D representation of pinacol. Now let's see what are the different steps involved in the mechanism of Pinacol-Pinacolone rearrangement. The first step involves the protonation of one of the OH groups of the pinacol and form OH2+. Now, in the second step, a carbocation is formed by loss of water from the protonated diol. So you can see here a carbocation is formed and a water molecule is leaving. Now in the third step, a rearrangement of carbocation occurs by 1,2 shift to give a protonated ketone. It is a methyl group from adjacent carbon is migrated to this carbon and a new carbocation is formed. Now in the final step, a protonated ketone is formed, that is C double bond OH+. This is deprotonated, that is NH+ is lost from the protonated ketone to form pinacolone, that is a ketone. Let's view the whole mechanism once again. We have seen the mechanism of Pinacol-Pinacolone rearrangement. Now let's consider another example in which the two carbon atoms are substituted differently. For example, in this compound, 2-methyl-3,3-diphenyl propane 2,3-diol. One carbon atom has two phenyl groups while the other carbon has two methyl groups. In the earlier example, both the carbon atoms were substituted by the methyl groups. But here, the two carbon atoms are substituted differently. We have seen that the first step of the reaction mechanism involves the protonation of one of the OH groups. So when this compound, when treated with a mineral acid, there are two possibilities. So either the OH group attached to this carbon, I have marked the two carbon atoms as 1 and 2. So either OH group attached to C1 carbon may get protonated, or the OH attached to the C2 carbon may get protonated. If OH attached to C1 is protonated, then from here a water molecule is lost, resulting in the formation of a carbocation, and this will rearrange to form product A. But if the OH attached to the C2 carbon is protonated, then the product formed will be B. That is, the phenyl group is migrated to the second carbon and product B is formed. So here there are possibilities for two products A and B. But actually only one product is formed. So which product is favored during this rearrangement? Is it A or B? Let's find out. The main factor which determines the formation of the product is the stability of the intermediate carbocation formed. We have seen that in the mechanism, the second step is the formation of the carbocation and its rearrangement. When the OH attached to the C1 carbon is protonated, this carbocation is formed, which is marked as 1. And if the OH attached to the second carbon is protonated, carbocation 2 is formed. Among these two, which will be more stable? We know that when two phenyl groups are attached to a carbon, that carbocation will be more stable because of a resonance stabilization. As you can see here, the positive charge on this carbon is dispersed or delocalized between the two benzene rings, so that carbocation 1 will be more stable compared to the second carbocation. That means the OH attached to the first carbon will be protonated, a water molecule is lost, resulting in the formation of this carbocation, carbocation 1. So if this is formed, then a methyl group adjacent to this carbon is migrated to this electron deficient center, which then forms a protonated ketone, and finally NH plus is lost to form ketone, which is product A. So we get only the product A because a more stable carbocation is formed only when the OH attached to the first carbon is protonated. So from this carbocation, only product A can be formed. There is also another factor that determines the formation of the product, and that is the migratory aptitude of the group attached to the carbon atoms. When each of the carbon atoms of the Pinacol has an alkyl and an aryl group, then the aryl group preferentially migrates. For example, here we have two carbon atoms which are substituted identical, but each of the carbon atom has a methyl group and a phenyl group, so an alkyl and an aryl group. If this is a situation, then the phenyl group will migrate in preference to the alkyl group. And this is related to the relative migratory aptitude of the groups, which you will learn in detail in your PG classes. Okay, so here the phenyl group will migrate and the product formed will be this. So there are two factors which determines the formation of the product during Pinacolone rearrangement. The most important factor is the stability of the carbocation intermediate. The formation of the product is favored only from a more stable carbocation. And another factor is the migratory aptitude. If a carbon atom has an alkyl and an aryl group, then the more preference is to a aryl group than an alkyl group, and the product is formed accordingly.